this is Joy. Today I'm going to show you how to design a simple BCD adder using simple binary adders, or 7483 rather. 7483 as already depicted is simple 4-bit parallel adders consisting of 4 full adders inside it, and we are going to use this ICs 27483 chips to perform simple BCD addition. Now, before going into detail, I want to explain you what BCD adder basically is. BCD adder is whenever a simple binary addition we get a number greater than 9, we get added up with number 6. We will add that number with 0 1 1 0. Whenever we get the binary addition result greater than 9, we will add 6 to this number. What is this? Let us take two numbers. It is 1011 equivalent to 11, and it is 0101 equivalent to it is, say, 5. So the result should be 15 in BCD, but we get a number that is 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, 1 plus 1 0 carry 1, and 0 carry 1. So we get a number 11 plus 5, that is 16, equivalent 16 binary number 1 0 0 0 0. So it is greater than 9, so we will add 0 1 1 0 to this number. 0 plus 0 0, 0 plus 1 it is 1, 0 plus 1 it is 1, 1 0 plus 0, so 0, and it is 1. So if we write in its BCD form, we will fill it up with another 3 so that it becomes a 4-bit number. So equivalent to this is 1, and equivalent to this is 6. So it is 1 6, that is 16, and matching the result we found here, that is 11 plus 5, that is 16 we found here. So matching the result. Now let us check how the BCD adders will be designed. How the BCD adders will be designed. If we see the truth table here, in the left you have got the binary sums, S0 stars, S1 stars, so on up to C star is the carry, and for BCD sum we have used simple S0, S1, S2, S3. Now you can see that up to 9, 0 through 9, you have the same BCDs and binaries. Up to 9 you have same BCDs and binaries. Whenever you are moving through 10 through the other numbers, you are getting different. How this can be explained? If you say 10 in decimal, its BCD equivalent should be 4-bit equivalents of each digits. That means 1 should be written 0 0 0 and 1, and 0 should be written as 0. So 1 and 4 zeros. If you write 11 instead of here, so it should be 0 0 0 1, and accordingly this table is filled up with the required results. As you can see, 10, that is 1 4 zeros, 11 1 0 0 0 0 1, simple, and filled up in this manner. Now one thing is worth remembering, that till 9 there is no carry generated, or the C bit is 0 in case of BCD sum, but whenever we exceed 9, we get a C output here. Simple. So for getting the C output to 1, we need to design the circuit depending upon this. That means we need to check in which cases C is 1. So in order to maintain that, first we will categorize these groups 10 through 19 into some groups. Let us take the 16, 17, 18 and 19 case, where the C star is 1, we are getting carry 1s. it does not depend upon S0 star through S3 star. It only depends upon the C star, it is 1, and the C out is becoming 1. So it should be written that for when we will add 6 to the number, when we will add 6 to the number, we will add 6 to the number when C star is 1. Next, in the upper all the cases, that is 10 through 15, we see that S3 is always high, and either of S2 and S1 is high, and the adding up is being needed. So S3 star dot S2 star plus S1 star. S3 star is always high, and either of this one high, making this C out in BCD high, so it should be taken care of that these two conditions need to be satisfied in order to add 6. Now what should be the design? This is the design. That means S3 star and S2 star is being ANDed, and S3 star S1 star is being ANDed and ORed with the C star, and this ORed output will be high only when these any of these conditions satisfied. It should be high, and it is given to the second 7483 chip in the B input, and the it should be 0110, so it is given to the middle 2 pins of B inputs, and the LSB and MSB is been grounded to provide 0 to it. And what should be the A input of the second chip? It should be the same output of S0, S1, S2 and S3. So let's go into the circuit. As you can see here, I have made a simple bus connection. This S1, S2, S3, S4 is given to A1 through A4. It is grounded. Initial carry has been grounded, and this carry, previous carry, it is here. S2, S3 has been ORed, ended up with S4, ended up with S4, that is we are performing S4 into S3 plus S2 equivalent to S3 into S1 plus S2, and being ORed with the carry, and given to the middle two chips, there is B1 and B2 and B3, and B4 and B1 are grounded to add 6 to the numbers whenever needed. Now we have taken this number, that is 1011 and 0101. Take 1 1 0 1 1, and we will take here 0 1 0 1, and the BCD output, the BCD output should be, as you can see, it is 6, showing 6. It is showing 6 here, and there should be no carry generated out here. And why it is showing 6 instead of showing 16? Because it is a 4-bit output, so it will take the addition of 11 plus 5 as 6, because total BCD number is 8-bit number, and the MSB 4 bits cannot be shown here as it gives only 4-bit outputs. So 11 plus